Okay, example 3. A ball is dropped from a building. Its path can be represented by this relation. H equals negative 5t squared plus 100, where h is going to be the height of the ball, and t is going to represent time in seconds that it takes for it to fall to the ground. Okay, so what's happening here, if we get a little idea of what this would look like, the graph actually looks an awful lot like real life. This is going to be time. This is going to be height. And what's happening is the ball is starting off at a certain height. It's on top of the building. And as time goes on, it's going to fall to the ground. So the ball is going to go like this. And the math that tells how it's going to fall is right here. Okay? That's the math that's going to tell us something about it. So from what height was the ball dropped? Well, this is a parabola. And this parabola, as we can tell, is going to have an equal symmetric side on this side. So this is going to be its vertex. That was the highest point. Well, we can tell that vertex, since it's in ax squared plus c mode, that the c is equal to 100. So the maximum value is 100 meters. Is it meters? Yeah, meters. So this is 100 meters off the ground. What is the height of the ball after 5 seconds? So we want to come out here and find out where 5 seconds is and determine the height of the ball. Well, the graph's not going to help me here. It's not accurate enough. So I have to use algebra. So what is the h value when t equals 5 is the question you're asking. So we're going to do h of 5. Now remember function notation. This just means I'm going to be putting 5 in for the t here. So it's going to be negative 5, 5 squared plus 100. 5 squared is 25. Okay, so 25 times 5 is negative 125. So what is the height of the ball after 5 seconds? Well, after 5 seconds must have been out here, because the ball, according to the math that we did, is supposed to be 5 meters or negative 25 below the x-axis, and the x-axis is ground level. So what we would say, barring a hole being in the ground or the ball falling through the ground and drilling a hole as it falls, we're going to say the height of the ball would really be 0 meters above the ground. So really what's happened is it's hit the ground. It's lying on the ground. It's just sitting there. It's not going anywhere. Okay? And it's been there for a little while. Example 4. The graph of the quadratic relation a x squared minus 20 passes through a point. Find the value of a. Well, this is a neat question. We've done questions like it before. We know that this point, when x equals 2, y equals 4, has to lie on this equation. So what we do is we take y equals ax squared minus 20, and we sub in x equals 2 and y equals 4. What we get is 4 equals a 2 squared minus 20. 4 equals a times 4 minus 20. We want to isolate for a. So add 20 to both sides. We want to isolate for a still, so divide both sides by 4. And we get a equals 11. Very straightforward. And I think we have one other question like that. The only difference is we're after c this time. So again, when x equals negative 2, y equals negative 1, this point lies on this equation, which means that when we sub in these values, it needs to work out. So negative 1, so that's going to be 4 times negative 4 is negative 16. We want to isolate c, so we add 16 to both sides. And c equals 15. Okay, guys, that's it. That's the last lesson for this year. It's been a pleasure teaching every one of you, and I hope to see you again soon in September. Okay, guys, have a great summer, and we'll talk to you soon.